Absolutely. So my name is Nils. I live in Hong Kong, where I'm calling from tonight, and where Aoki has its headquarters. Aoki is building a decentralized machine perception network. That is, in a way, you can think of it as a collaborative, external, and interoperable sense of space for devices, robots, AI, AR glasses to connect to. It's somewhere between a GPS replacement, a 3D map of the world, and a real-time communication network for robots. We call it a decentralized machine perception network. We started building this in a way back in 2019 when we wanted to create augmented reality experiences for the tabletop game Warhammer. And while doing that, we learned that it's actually very difficult to create shared augmented reality experiences using phones and glasses, because digital devices don't have a very good understanding of physical space. The GPS is nowhere near precise enough to be able to have those kinds of fine-grained experiences. So between 2019 and 2021, we worked really hard on solving the positioning problem. And in 2021, we had invented something and patented something that allowed us to pivot into becoming a full-time just protocol company. So now we're building this protocol, the Decentralized Machine Perception Network. And on top of that, we are building a couple of applications, but also other startups and some very big companies are building applications on top of this network to help their machines and digital devices better understand the physical world. I think it is very exciting to see such a large amount of money be invested into AI, but I think the investment is somewhat misplaced. To explain why, there are two important pieces of news that are worth discussing. One, earlier this year at CES, Jensen Huang, the CEO of NVIDIA, explained that we are now entering the era of agentic AI, something that, of course, the crypto world in particular has paid a lot of attention to. But Jensen pointed out that the next and final frontier of AI is something he calls physical AI. And physical AI is an AI that has an understanding of the physical world and an understanding of physics. And today, AI doesn't have that. So rather than investing in GPUs, maybe we should do what Aoki is doing and invest in establishing a decentralized network of sensors so that AI can get a real-time understanding of the physical world. I also think it's worth noting, for example, that DeepSeek, a Chinese LLM company, recently got a very similar result to ChatGPT, but with only a fraction of the GPU. So it's possible that the future of AI doesn't need as many GPUs as this 500 billion will allow. I believe that the future of AI doesn't need more GPUs, it needs more sensors. That's why we are building this decentralized machine perception network, because we want to make the physical world AI accessible and become the platform for physical AI. So about a year ago, I think a year ago and a few days, Apple released the Apple Vision Pro. And when they released the Apple Vision Pro, they didn't call it a headset. They called it a spatial computer. And I think the reason why they did that was to draw attention to its most important feature. The most important thing about the Apple Vision Pro is not that it's a headset, it's that it's a computer that understands the physical world. An Apple Vision Pro and a robot have a lot in common that way. They are both spatial computers, computers that have to understand the physical world. In fact, I believe that 10 years from now, the largest operating system in the world will neither be iOS nor Android. It will be some new operating system made specifically for AI and specifically for spatial computers. It's with that vision in mind that we have been building out collaborative spatial computing. Last year, we showed off 2 really amazing proofs of concept of what you can do with collaborative spatial computing. One, we did together, the founders of Mentra, an AI glasses company. Together, we built a wearable device that retail staff could wear that would stream its video and accelerometer data in real time to an edge computer on the decentralized network. And that edge computer would take care of the spatial computing on behalf of the wearable. This is meaningful because spatial computing is actually incredibly battery intensive. That's why, for example, Meta's AR glasses only have about half an hour of battery. But with only 300 grams of hardware, which is less than an Apple Vision Pro and only a little bit more than Snapchat's AR glasses, we could get 9 hours of battery out of this device because through decentralization and collaborative spatial computing, we moved the compute to another computer on the network. And because it was a hyper-local edge machine, we could still have acceptable latency. Another really meaningful demo that we showed off last year was having different cameras in a physical environment be connected together to the external sense of space, so that when the cameras detect something, a task could automatically be created on a phone that is also connected to the sense of space, so that a human or a robot could navigate precisely to the issue that was found. We showed this with empty shelf detection in a retail environment. So we had several webcams looking at the shelves in the store, and as soon as any product ran out, as soon as there was an empty shelf, not only could we know that there's an empty shelf, but we could know exactly where that empty shelf is, and by inference, even know what product was missing. So these are 2 incredibly powerful use cases of decentralized and collaborative spatial computing. Just for context, globally, retailers cumulatively lose about 0.9 trillion, 900 billion empty and mismanaged shelves. So bringing spatial AI into retail environments is going to solve many billion-dollar problems for retail. And that's something that we like to focus on because we believe that if you want to see billion-dollar burns, you have to solve billion-dollar problems. So the Postmesh is the name of the protocol that makes the Auki network run. So the Auki network runs the Postmesh protocol. You can think of the relationship between the Postmesh and the Auki network, kind of like the relationship between blockchain and Ethereum. The Auki network is a specific implementation of a Postmesh, and a Postmesh is a kind of solution that we invented. We were the first to build one, but there are other people now trying to build their own Postmeshes as well. We believe ultimately that DePIN as a movement will eventually graduate into focusing almost exclusively on connecting AI to the physical world. You can think of it this way. There are 2 kinds of DePIN today. There are DePINs with fungible infrastructure and DePINs with non-fungible infrastructure. Fungible infrastructure are things like decentralized GPU networks, things like Kosh or Aether. The problem with, or what characterizes a fungible piece of infrastructure is that you can, in most cases, remove one server in Singapore and move that server to Vietnam instead. And for most of your users, there's not going to be any noticeable difference. The compute is fungible. You can replace one server with another server, and the quality of your service will not meaningfully deteriorate. But non-fungible infrastructure is infrastructure where if you remove it or put it somewhere else, you've really changed the quality of that network. For example, if you have a camera in Singapore and move that camera to Vietnam, you now have a very different network, because before you could see Singapore and now you see Vietnam instead. That's not the same network at all. And what's interesting with fungible versus non-fungible is that all fungible infrastructure networks are essentially just competing on price and convenience. So they are in a race to the bottom on pricing, whereas non-fungible infrastructure like GeoDNet or Natix or HiveMapper or Aukey, these non-fungible infrastructure networks can build up a much more reliable moat and can defend themselves better. So I think that the DePIN as a movement is absolutely unstoppable, but ultimately the winners of DePIN are going to be the non-fungible infrastructure projects. And the most important non-fungible infrastructure projects are those that allow AI to better connect to the physical world. So these are projects like Helium that allows for internet connectivity everywhere. It's projects like Natix and HiveMapper that can provide camera data from everywhere. It's of course also projects like OVR and Aukey that can turn that kind of image data into positioning for robots. It's projects like GeoDNet that can provide RTK positioning. These kinds of DePIN projects, I think, are some of the most important things that humanity has going on right now because they are making the world AI accessible. So we are already rolling out live in the world spatial AI that can perceive the world collaboratively through a network of sensors. So we can, for example, collaboratively reconstruct a supermarket. We can collaboratively monitor the state of the shelves in the supermarket, and robots and AI can use this sensor network to understand what is happening in that physical space. We think we are on track. I mean, right now we're rolling out into over 1,000 locations, and I think we're on track to roll into over 100,000 locations by the end of 2020. And the reason why, of course, is that physical businesses want AI too, but AI can only act on digital information. So making the physical world into a digital representation in real time is a prerequisite for AI being able to help. One of the startups that's building on top of Aukey, for example, they're called Sabrina. They're building something that I think is very illustrative. They wanted to use generative AI, LLMs, to make a house renovation assistant. You know, you're renovating your house and you can ask questions like, where should I put the electrical socket? How many square meters of tile do I need to redo my bathroom, etc.? The problem was that LLMs don't have any kind of spatial understanding, so they aren't able to answer questions like that very well at all. But by combining LLMs with Aukey, Sabrina is able to build a spatial renovation assistant that actually understands how to improve the physical space. Robots are still a very early platform. Integrating phones and headsets into DePIN is a lot easier today because they have more mature software platforms. But the robots you see are still very, very early in their development. So they can walk around and keep their balance and they can get up if they fall, but they don't have very much reasoning at all. There's no AI really inside of the robots apart from their ability to balance and walk. So there's a lot of work left to be done to really teach these robots to become physical AI. Of course, Aukey's very strong hypothesis is that we have to start with teaching them to operate the physical space. There are other people building LLMs, and that's great, but someone has to focus on the robot's ability to perceive the world, and that's where Aukey is spending its R&D. So we are working with robot companies from all over the world now, but of course mainly from China, because right now China is #1 when it comes to robotics. And the state of the hardware has improved a lot, but there's still a lot of work left to do on the software, not just in Web 3, but in Web 2 as well. And I think Aukey's position, straddling between Web 2 and Web 3, has guaranteed us a very interesting seat in history in 2025. I think the most impactful thing that humanity can spend their time on over the next 10 years is to make the physical world more AI accessible. And that means innovation in a couple of fields. Since Arcreen is doing innovation in energy, maybe we can talk a little bit about the energy challenges related to making robots be able to really navigate the world. One of these fantastic dog robots, for example, that you see, they only have 2 to 4 hours of battery. The humanoid has 30 to 60 minutes of battery. So these are very limited operating times and therefore also very limited operating range. We are entering I think we should think of it as the battery century, right? Where before, in the previous century, as we used electricity, we mainly used electricity by things connected into the wall. And the exception, of course, was our phones and our laptops. But increasingly, most of the world's electricity will start going into batteries. Batteries of self-driving cars, batteries of robots, batteries of drones. I think within 10 to 20 years, there will be many robots per human. And all of these will have batteries that will need to be able to swap out, to recharge. I'm very excited to see, for example, that in Shanghai, they now have hot swappable batteries for self-driving cars. This is an important piece of innovation. And there's a lot of innovation left to be done in how energy can be moved around the world. Because if you want to be able to send your humanoid robot to the grocery store to go shopping for you, it needs to have enough battery to leave your home, to make it to the store, to do the shopping, to carry everything back. And probably what we will see is battery swap stations, especially in big Asian cities that take these kinds of things seriously. There's a lot of innovation still to be done in how can we move energy from one point to another and make sure that our robots always have battery.
Great. That's all for my questions. Thank you for sharing your insights. So today we had the pleasure to hosting Niels, CEO of Alki, a pioneer in deep and AI project that empowers decentralized machine perception, enabling AI to truly understand and interact with the physical world.
Nami, I have to say, these were fantastic questions. Thank you so much for preparing them. This was a really to-the-point interview. I really appreciate it.
Yeah, thank you. Thank you for joining us, Niels. See you next time.
See you next time. A quick shout out to all of the people from the Alki community that I see here too. Very nice to see you all. Make sure to follow the great people at Arcreen as well.